Today we're discussing similar polygons. We're going to see what we did in the past. So previous days we talked about ratios and how ratios can make up proportions, like this equation where we can cross multiply and divide possibly, and what it has to deal with similar polygons. So the essential question of the day, how can we determine two polygons are similar? So they are only similar if two polygons have corresponding angles that are congruent, and the corresponding side lengths are proportional. We're going to get this definition down and decorate our picture to the best of our ability. So when we're trying to determine if corresponding angles are congruent, you start listing them. Like, all right, bottom left angle A is congruent to the bottom left angle E, and then angle B is congruent to angle F, and so on and so forth. They have to be the same measure in order to be the same shape. All right, so let me explain. First off, last semester we talked about congruent polygons. And when you had congruent polygons, they were the same shape and same size. So everything was congruent. Angles were congruent and sides were congruent. But now we're going to have different sizes. So they have to be in a comparison sort of deal. So AB compared to EF needs to reduce to the same fraction as BC to FG, which should reduce to the same fraction as CD to GH. That's what we mean by sides. Corresponding sides need to be proportional. We're going to see that on the next example. So go ahead and turn your page in your notes. Copy the picture. So here's what we're doing. I'm telling you triangle PRQ is similar to triangle STU. So right away we know that corresponding angles are congruent. Let's list them like last semester. So recap, we wrote down the corresponding angles that were congruent, and now we're going to write the ratios of corresponding sides. This is new, follow my lead. What you do is we're going to use the name as a guide. First two letters, PR, is going to be matched with the first two letters in the next triangle's name, ST. We're going to test this to make sure that this correspondence is the same reduced ratio as RQ, the last two letters in the first name, and the last two letters in the second name, TU. Sometimes the pictures definitely line up. These two pictures definitely line up, but sometimes it'll be rotated. First and the last letter compared to the first and the last letter in the names. So now let's go to the pictures. Let's put in those numbers. And then we'll check to make sure that they reduce in ratio, or that they reduce the fractions. So putting in the numbers corresponding with the sides. So PR, the number in between P and R is 10. So that's why we put a 10, compare it to ST, which is 8, and so on. We're going to make sure these three ratios reduce to the same fraction. So now create another line in your notes so that this is a definite division. Letter C is asking to make sure that the ratios reduce to the same fraction. So in order to reduce the first one, they're both even, so let's divide them both by 2. Reducing it to a 5:4 ratio. And we're going to check to see what the other ones will reduce to. So in the next fraction, again, it does reduce to a 5:4 ratio. And then the last one, they both share 3. And we're left with a 5:4 ratio. So yeah, those ratios reduce to the same. So this is just checking to make sure all the areas of being similar polygons work. So in this next example, we're going to decorate our picture, and now we're looking at something that's not a triangle. And we're going to go through the same steps of just discovering what it all takes to be similar. Congruent angles have to exist. Corresponding corresponding sides now need to be proportional. We list all the congruent corresponding angles using the name, or using the picture as long as we can tell that it's not rotated. So create a new line in your notes. Let's go through and list the corresponding parts, corresponding sides. Like what side in the left figure will be corresponding to the side in the right figure. And we're going to set it up as a ratio, set it up as a fraction. I'm going to recap this for a moment because I forgot to record that comment. But you take the first two letters, JK, and that's going to be compared to the first two letters, NP. That's written as a fraction. Then you take the next two letters, KL, over PQ. Continuing on with that pattern, LM to QR. So now we're going to use the numbers. JK has the length 8, and P has the length 4. So I'm going to have that 8 to 4. And we continue on. KL, 4 to PQ2, and so on. All right, in the first fraction, let's reduce top and bottom by 4. In the second fraction, reduce by 2. In the third fraction, let's reduce by 5. In the last fraction, let's reduce by 3. I'm confident in your reducing skills. We're going to see if we end up with the same ratio. So after doing that division, we do end up with the same ratio everywhere. So we're just checking the similar process. Do we, map out the corresponding angles, making sure they're congruent, mapping out the corresponding sides, setting up these ratios. Because now we're not going to have all the information. Now we're going to kind of work backwards. Let's start with the ratios. Will these ratios end up reducing to the same thing? Will we have similar polygons? In the next example! Oh wait, we got to learn about a scale factor first. The ratio of these lengths, or this reduced fraction that we end up with, is called a scale factor. I need you to copy this on the next page, on the page you're at, to the best of your ability. Completely put it in. Put in all the arc marks. Put in that A in the middle. Put in that B in the middle, because we're going to definitely make sure we read these figures going from the A figure to the B figure. Making sure we read it left to right. Just by glancing at this picture. If I just look at the angles, angle H is congruent to angle K. Angle G is congruent to angle M. Angle J is congruent to angle L. I could write them all out, or I can just notice all the angles are congruent. Now let's go to the sides. Let's match up the sides. So going through this picture, the one arc to the two arc side, HG matches the one arc to the two arc side, KM. One arc to the three arc, HJ matches KL, and so on. GJ matches ML. Let's put in those numbers and reduce those fractions. Do we come up with the same fraction? After we reduce it, after we reduce those numbers, do they come out to be the same ratio? If they do, that's the scale factor. So after the reducing, we get the same fraction all the way through. If you get the same fraction all the way through, these two triangles are definitely similar. So 3/4 is the scale factor. And then let's reread the directions. Determine whether the polygons are similar. If they are similar, we need to write a similarity statement. I'm going to put this in green. Write a similarity statement. Similarity statement is where you have triangle blah 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 is similar to triangle blah. So that's what we used to do with like HGJ. Triangle HGJ is similar to KML. It's practicing the new notation of the similar sign. You might be like, wait, what's the similar sign? That is the similar sign. That tilde. So scale factor is 3/4. We've got similar triangles.